All right, I'll go ahead and start the review and let's see. Okay, starting with number one, find the average rate of change. So average rate of change, there's no calculus involved. It is just slope between endpoints. And so we're just really finding these order pairs. 0 and 1 are both representing seconds. So we need to find the miles associated with each of the 0 and 1 second. So then we plug 0 into S sub t, and we know that at 0 minute, 0 seconds, this object has gone backwards 1/3 miles, or negative 1/3 miles. And then 1 second in, he's going to be at negative 1/2 mile. Whatever that means. So imagine this is just locations on a number line. So it's at negative 1/3, and then at 1 second, and he's at negative 1/2. So then we just want to find the rate of change. So it's going to be the change in miles divided by the change in seconds. So S sub 1 minus S sub 0 over 1 minus 0. You can leave your answer unsimplified. That's fine. So then we know that between 0 and 1 second, that his average rate is negative 1/6 miles per second. Number two, still more average rate of change. So we're given 6 and 50 in terms of items. So maybe this is talking about production cost. If you only produce 2 items, then you're losing this amount of money. But the more that you produce, then the more money that you're able to get in return. So we're just doing average rate of change. So we want to find the amount per item. So we just find the associated Y values. So we want to use order pair 60, negative 100, and then order pair 500, 2500. So we just do change in Y over change in X, or change in our dependent variable divided by the change in my independent variable. And then we just also represent our units of measure, dollars per item. Same process with 3. Okay, number 4. Use limit to represent instantaneous rate of change. Identify the original function. So for number 4, this is supposed to match well with one of the definitions for limits. One of the well, in fact, it's matching nicely with the alternate definition, limit definition of derivative. So if we can match those parts there, f prime of c is equal to a limit as x approaches c, f of x minus f of c. And if we can recognize that, oh, this is just applying that definition of a limit. So this is kind of working, plugging it in, but then not working all the way through. But if we just understand where this is coming from and what it's asking, we can just go back to the rules that we're more accustomed with and not have to go through this whole process. So the idea is that we see that, oh, this 1 over 10 plus x, that represents my f of x. And I know that this represents finding the derivative at a point. So we're basically, and we know that the c value is 1. So basically this is saying find f prime of 1. So if we know what this represents, and if we know what it's asking, then we can just solve an easier problem, or a problem that has easier steps, right? Imagine this is the starting point. If you're given this function and finding the derivative at 1, you would find the derivative going through quotient rule, and then you will plug 1 in to get the slope. So then we can just transition over to solving this problem now that we know what this is asking. So if we think of this as quotient rule, f prime g minus f g prime. Let's find f prime first. Remember, the derivative of a constant is going to be 0. So that's going to wipe this whole thing out. I'm just left with negative 1 over 10 plus x squared. So now I can find f prime of 1. Now that I have my slope formula, I can find the exact steepness at a specific point. Any questions with 4? Okay, number 5. We need to recognize this as referencing the general definition of the limit definition of derivative. So f prime of x is equal to limit as h approaches 0, f of x plus h minus f of x. So we can kind of tell by looking at both of these that if I were to replace this 5 plus h with x, or replace that 5 with x, I can see that my function that it's referring to is 2 to the x. And we know that this notation represents, oh, it's asking to find the derivative of a function, but the x got replaced with 5, so this is asking for the derivative at a point. So this is basically saying find f prime of 5. Everybody okay with that? Okay. Now, we haven't learned this derivative rule yet, so no, I'm not going to put this on the test. But even if I did, I would give you the rule when the derivative of a to the u is natural log of a times a to the u. So therefore, if we want to find the derivative, f prime of x, this is my a, this is my u. So it's just going to be natural log of 2 times the original function, 2 to the x. And then to find the derivative, just plug that 5 into the derivative, so f prime of 5. Leave your answer unsimplified. But I'm not going to give this to you. We haven't learned this rule, but we should still be able to understand what it's referring to and what it's asking us to find. Number 6, find the equation of a tangent and a normal line. So let's just worry about tangent. So let's just find f of -2, and we'll find f prime of -2, and that'll give us our order pair and our slope. We'll build our tangent line, and then we can worry about what to do with the normal line later. But it's going to be it's just a slight adjustment to get to the normal line. Okay. So first, let me just go ahead and find my order pair here. Next up, I'll go ahead and find my y prime, my derivative, which I can then use to find my slope. So plug -2 in for x, I get -4 plus 6, which is 2. So I know that my point is -2, 1. My slope is 2. And now I'll do point slope form. So here's my tangent line. And to get to my normal line, I should have to make a slight adjustment. I can use the same point. I should need to adjust my slope. So normal line is perpendicular. So the slope I want to use is now going to be the opposite reciprocal of this slope, so I can make it 90 degrees. So I can form a 90-degree angle with my original slope. So to get to that, I could just take that number, take the reciprocal, so 2 becomes 1/2, and change the sign, so it becomes -1/2. I'm still using the same point. Point slope form.
You always leave it in that like
Yes.
unspecified.
Yes. I would strongly suggest that you do it because this saves time, and College Board accepts it. So I would always leave it like that. I mean, if you kept going, it's not wrong, but
Yeah.
two things: you're introducing the chance that you can make an mistake, and you're spending more time on something that you could be spending elsewhere. But that's your decision. Okay, number 7. Same process, but we do need to do a little bit of cleanup, get that root x to be x to the 1/2 first, so we can get it ready for power rule. But we can go ahead and find the order pair first. And then focus on finding f prime, and then finding f prime of 9. So it really doesn't matter which order you gather your information. For me, I decided that I wanted to find my order pair first. So I plugged 9 into my original function. I got 30. Okay. And then once I have my order pair, I can get myself ready for my derivative. So here's my function, my derivative using power rule. So bring down the 1/2, subtract 1 from the exponent. The 4x becomes 4. Once I have my derivative, I know that this is how I can reach my slope. So plug 9 into my derivative to get my slope. And then this is the slope of my tangent line. So I have my slope is 11/3. My order pair is 9, 30. So I have the information to build my tangent line equation. That's going to be the one that's going to feel more straightforward. The normal line, just have to make a slight adjustment. We want to find the opposite reciprocal so we can create two lines that are going to intersect at 90-degree angle. So the way you get to your perpendicular slope is you take your fraction, or if it's not a fraction, you can always form a fraction by putting a 1 in the denominator. And then you flip it first, and then you change the sign. So there's two things you got to do to get it to that perpendicular slope. So here's my perpendicular slope. I can use it in point, and then put into point slope form. Okay. Any questions? First page. Hmm? Yeah. So number 5, we need to recognize that this is really referencing the general definition of derivative. And if we look at how this is set up, if we just replace the 5 plus h with x, or replace the 5 with x, we can see that, oh, that's really coming from the function 2 to the x. And the 5 is there because the 5 is replacing the x. We know that this whole thing represents find the derivative. But if I replace the x with 5, then it's asking for finding the derivative at a point. Now, we haven't gone over this derivative rule yet, so this won't be on the quiz, but we know what it's asking us to do. Okay, here's the function, find the derivative, plug in 5 to find the slope. And so how do we know that's 5? Because you see how the x got replaced with 5? And we know that this whole thing represents f prime of some x value. So just kind of piece this puzzle together.
If there's an h in like the original equation, will always be that with the definition of x plus h.
Yeah.
Is it instantaneous rate of change that same as just slope?
That's right. It's a slope at a specific point. So if it's instantaneous rate of change, that means find the exact slope, which usually requires calculus. But if it's average rate of change, then there is no calculus. It's just slope between endpoints. Okay, everybody good? First page. We do have to make sure we recall all of our derivative rules. So power rule, natural log rule, e to the x rule, and then all 6 trig functions. So we first find the derivative for f of x, then we can plug in 0. So cosine becomes negative sine, e to the x stays e to the x. Once we have our derivative, plug 0 in. Remember, we have to resolve our trig. We have to get this down to some number here. So sine of 0 is 0, e to the 0 is 1, so 9 times 1 is just 9. Next up, or natural log of x minus 3 e to the x plus e. Natural log of x's derivative is just 1 over x. E to the x stays e to the x. E is not a variable. E is a number. E is like 2.7. So we know a constant will go to 0. Once you have your derivative, find your slope. Plug 1 in for all the x values. That will get you your slope. And 4 minus 3e is good enough for the answer. We know the 4 is just a coefficient, so it's just kind of hangs out in front of the variable. So that's 4 is not going to go away. It's the natural log of x that's going to get impacted. So the derivative of natural log of x is just 1 over x. Now, if it was 4 plus natural log of x, then that 4 would go away from 0. Okay, moving on to 10. Being able to recognize when there's a need for product rule, when there's a need for quotient rule. For A, there is a need for product rule in order to build our derivative before we can deal with what happens with that -1. So I'm just going to call the first expression that I see the f, and then the second as my g, and I'm just going to build my derivative. F prime times g plus f g prime. I'll let the 2 tag along with the j of x, and I'll let that be my f. So then once we find our derivative, we plug -1 in for all the x's, and then we refer to our table, make our substitutions, and we get our slope down to a number. Next up, part B. There's also a need for product rule here. We got parentheses multiplied by another parentheses. But this j of x over 2, you may feel like, oh, I got to go through quotient rule here. If I'm dividing by a constant or a number, I can always push it out and think of it as a fractional value times a variable. And the reason that I would want to rewrite it in this form, because then it's easier to recognize, oh, I don't have to go through any sort of product or quotient rule. That 1/2 is just going to be a number in front, and that feels a little bit less intimidating than looking at that 2 below, right? So I like to pull that 1/2 out in front. It's just the same thing as if it was just a 2 or 3 or 5. It's just some coefficient in front. So I like to start at this stage and recognize that the only thing I need is going through product rule. F prime g plus f g prime. So the derivative of 1/2 j of x is just 1/2 j prime. The -4 goes to 0, so that's why it drops out. My g function, I'm just going to carry that down, minus my f function, I just carry that down, and then the 1 goes to 0, minus kx becomes -k prime. Number 11, we see that there's a need for a quotient rule. So we go through quotient rule, f prime times g minus f g prime all over g squared. And number 12, secant derivative is secant tangent, and natural log's derivative is 1 over x.
Is it possible that theta is gonna be a variable? Like, on number 11,
Theta is what?
like a variable, like x, not like a number.
Oh, wait, theta is a variable.
So
Yeah. So it will always, yeah, it could be r equals x over tan of x. Is that what you're asking? Yeah. Yeah, so if it's x or theta, just treat it like how you would x or theta or a variable.
Why are you subtracting?
For which part?
10p.
Oh, right. Let's see. Yeah, I should be adding. I don't know why I did that. Let me double check. But yeah, you're right. It's product rule, so it should be adding. See what went wrong.
I think you would still do subtraction limit because there it's like 3/2 minus 4, which gives you a negative. So you would still end up with the same.
Yeah. But I think. Yeah. Let's see. Yeah, let me look at that a little bit later, but why don't you work it out the way that it's supposed to be and see if we get the same answer. If we do, then that's fine. But if not, then let's see. Okay, yeah, so I had my notations wrong. The reason why I made two mistakes and it ended up canceling each other out, giving me the right answer. But yeah, this should be a plus here. And then -5/2 times 6 ends up giving us -15. 8 minus 15 is still -7.
Stop. How do you know when to stop?
Yeah, I'm not going to be picky about how much you clean up. As long as you get some version of the answer, it's good enough. But having said that, if it was multiple choice question, they may go further. And the way they could go further is they would split this up into individual fractions and then simplify each individual fraction.
But we're-
No, you're not supposed to do that. Even on the AP exam, you're not supposed to do that if it's free response. But if it's multiple choice, you just have to see how far they go in their answer choice. Number 13, you're just finding the derivative, evaluating the derivative at that point, knowing your unit circle values. And you can't represent your answer with any trig involved. It's got to be a numeric value. The numeric value doesn't have to be simplified, but it just has to be all numeric values.
So number 16.
So we basically want to know how can we make sure that these graphs are differentiable at -1. So if it's differentiable, two things has to happen. We need to make sure that these two graphs are going to actually connect at -1. Because we have to find the A and B values so that things will line up nicely. And the second is that not only do we need them to connect, we need them to connect in a way where there's a nice transition from one graph to the next so that the slope is the same at that point, so the graph will be smooth. So we're going to set up some scenarios to allow us to get those two conditions to work out. Because we know we want them to share the same y value, we're going to set their equations equal to each other, plug in -1 for x, and that will be one equation that we can work with. So basically, I'm plugging -1 in, and I'm just, a lot of times, this may not solve all the way. If it doesn't solve all the way, you leave it and you go to the other equation and then use two equations to help solve for one variable at a time. But in this case, it ends up solving already, so we just get a equals 3. But even if it is unresolved, we still go to the next piece of information. We still don't know what b is. So the fact that they're differentiable means that we must be able to share the same slope as well as the same order pair at that point. And we know slope comes from derivative. So we have to build the derivative holding on to these constants. And, a and b is just some unknown number. It could be a 3 or a 5 or 6, but it is not a variable. It is a constant. So the derivative of bx squared becomes 2bx. 3 goes to 0. So my derivative to the left of -1 is 2bx. And to the right of -1, the derivative of ax plus b is just a. Imagine this is 3x plus 4, right? If it was 3x plus 4, your derivative would just be 3. Same thing, ax plus b's derivative would just be a. Now that we have our slope formula, we need them to share the same slope at -1. So I'm going to set them equal to each other, replace all the x's with -1, and then see what I have left. -2b equals a. I have two unknown constants, but the good thing is I already have information from here. I could use that 3 to plug in, help this one out, and solve for b.
What we do if like the first equation like doesn't like go away by itself? It's like not a number.
If it's not a number, then you just plug into the other one. Let's say the first one ends up being -a plus 2b equals 3, right? It's unresolved. But then the second one ends up being 2b equals a. Then I just solve for one variable, substitute, then solve for the other. So 16 is a very popular type of AP exam questions that has shown up quite a bit. So 16 is general definition of a derivative. Sorry, 17a is general definition. 17b is alternate definition. So the first thing we do is you take your definition and you replace every c with the number that you're dealing with. So replace every c with 5. Things will become more clear once you get that c to be replaced. And once it's in terms of 5, then you look to see what you can do. It's always the numerator that you're trying to get out of function notation. So f of x is just the original function. F of 5 is just asking you to find the y value at 5. So once you have that, then you're just off to working your limit problem. So clean up your numerator. You're looking for plug in 5. You should get 0 over 0. I forgot to show the direct substitution step. And once you get that confirmation that there's a hole, you plug 5 in, you get the hole, and then you got to clean up to a point where you can factor a 5 out, get a factor of x minus 5 in the numerator so we can cancel out. So this cleans up all the way to -1 factored out, 2x squared plus x minus 55. We go through our factoring steps. This trinomial factors out to be x minus 5 and 2x plus 11. X minus 5 cancels out, the -1 stays. Replace the remaining x with 5. And I didn't show the answer. Yeah, we'll get the same answer on both sides because it's the same function, just a different process, a different method.
I don't know the definition. You have to solve for it, just like solve for the derivative.
Yeah, you solve for you find the derivative function, and then you plug in the number to get the slope. So the general definition will lead you to a formula the alternate definition will bypass it and take you directly to a number. I'll talk about 15 for a second. 15 is the most labor intensive of all of these problems. I'm going to give you a problem like this and ask you to not use quotient rule. There's only one term in the denominator. I want you to go through power rule, but a lot of cleanup before we can get to power rule. So you have to expand all the numerator out. You got to split up your denominator into, you got to split up your fraction into as many pieces as you see in the numerator. Bring all the denominators up by subtracting exponents. And then once you get everything cleaned up, then you're just going through power rule. And then the only thing I ask once you find your derivative is bring your negative exponents back down.
Thank you, sure.
All right, see you in C class. Bye, Tim. All right, see you later. Same as 17a, negative 21. All right, see you guys.